Good day to you children. In today's class, we will be learning about nth term of an arithmetic progression. To know what is the nth term, first let us look at an example, okay? Consider the arithmetic progression 2, 4, 6, 8 and so on. Consider this arithmetic progression 2, 4, 6, 8 and so on. We know that it is an arithmetic progression because there is a fixed difference between every other consecutive terms. Like the difference between 2 and 4 is 2, 4 and 6 is 2, 6 and 8 is once again 2. Okay, so now what I want you to do is I want you to find the 30th term of this arithmetic progression. Okay, what I want you to do is find the 30th term of this AP. Okay, so according to the traditional method, what we have to do here, we know A, we know A2, we know A3, we know A4. Like that we have to find A30. So you will have to go on adding 2 to every term you obtain, like 8, 10, 12, 14, but that is a lengthy process, right? Okay, even if we assume that you can find the 30th term, but what about if I tell you to find the 150th term? That is A150. It is possible, right? Because this is an infinite arithmetic progression. There is no end to it, right? So what if I told you to find A150 or A200 or A250 or A1000, like that? How are you going to find it? You cannot add everything. You cannot just go on adding. It will be too lengthy for you to do and too tedious. So what we got here is a shortcut method to directly and quickly find any term we want for any particular AP. Okay, any kind of AP, say it can be 3, 6, 9, any kind of AP, and we can find any term of that infinite arithmetic progression with a shortcut method, or we can say that there is a formula to find the nth term of an AP. Okay, so what is that formula? Yeah, I hope you remember the general form of AP, right? What is the general form of AP? It is A plus D, A plus 2D, A plus 3D and so on, right? So first term, that is n is equal to 1. When n is equal to 1, A1 is equal to A. That is our first term. Okay. When n is equal to 2, right, the second term, A2 is equal to A plus D. Agree? Now, when n is equal to 3, A3 is equal to A plus 2D. Okay, in the first class I told you how this A plus D, A plus 2D came about, right? If you don't remember, go back to that video. Okay. Now, similarly, n is equal to 4 is what? A4 is equal to A plus 3D. If we continue like this, if we go on continuing like this, then where an will be what? How much? What will be the value of an? And n is equal to some number n. Going by continuing like that, what will be it? If you observe it here, when n is equal to 2, it is A plus D. When n is equal to 3, it is A plus 2D, right? So when n is 3, we have multiplied 2 to D. Similarly, when n is 4, we have multiplied 3 to it, right? We have multiplied a number to the D which is one less than the value of n, right? So I can confidently write an is equal to A plus n is equal to n, right? So A plus 1 less than n minus 1 into D, right? So an is equal to A plus n minus 1 into d is our nth term of an AP, right? Now, if I were to substitute values for n, I should get this general form back, right? Let us verify. Let us verify for n is equal to 3. When n is equal to 3, what should you get? We should get a3 is equal to a plus 2d, right? So let us see if we will get that using this formula. N is equal to 3, right? So put in place of n, replace it by 3. So a3 is equal to a plus 3 minus 1 into d. So now we get a3 is equal to a plus 2d, right? It is right? A third term of an AP is a plus 2d. Similarly, a4 will be is equal to a plus 3d because n minus 1, 4 minus 1 is 3. Okay, now let's go ahead and look at the examples. The very first question of your solved examples is, find the 10th term of arithmetic progression 2, 7, 12 and so on. So what they have given you here is, they have given you an arithmetic progression and they have asked you to find its 10th term. Okay, so let us first write given AP. They are given us an AP, right? 2, 7, 12 and so on. Okay. Now in an AP we have A is equal to, in this AP A is equal to 2, D is equal to, we have seen in previous examples, D is always the difference between consecutive terms. So it is 7 minus 2 which is equal to 5. And what they have asked us, they have asked us to find the 10th term. That means n is equal to 10. Now we have A, T, N and we need to find A10. It is equal to how much? Okay. So now we know that from the, we'll use the formula. We know that AN is equal to A plus n minus 1 into D. Okay. So now n is equal to 10. So A10 is equal to, A is 2 plus n is once again 10 minus 1 into D. D value, the value of D is 5. So now A10 is equal to 2 plus 10 minus 1 is 9 into 5. Now applying D mass rule, that is division, multiplication, addition and subtraction. We have to first multiply. 2 plus 45. 9 5s are 45. So A10 is equal to 47. This is our answer. Let us write it down now. Therefore, the 10th term is, A10 is equal to 47. So what we did here was, we had an AP 2, 7, 12 and they asked us to find its 10th term, that is A10. We knew n is equal to 10. We found out D by just subtracting the consecutive terms and we knew we had A is equal to 2. So we substituted everything in the formula. AN is equal to A plus n minus n into D. So we got A10 is 47. So now moving on to the second question. Okay, in the second question, which term of AP 21, 18, 15 and so on is minus 81? Also, is any term 0? Okay, in this they have given us an AP, that is 21, 18, 15 and it goes on like that. And they have asked us to find out which term of this AP is minus 81. Okay, and also moving ahead in the question, they have also asked us to see which term of this AP will be 0. Okay, so here they have given us an and they have asked us to find the value of n. Okay, so let us work it out. Given from the AP, A is equal to how much? A is 21. D is equal to how much? It is the difference between consecutive terms, that is 18 minus 21, A2 minus A. We get it equal to be minus 3. Okay. So now AN is equal to minus 81. Let's work this problem one step at a time because there are two questions. Let's work one before and one later. So now N is equal to how much? So we know that AN is equal to A plus N minus 1 into D. AN is how much? AN is minus 81, which is equal to A is 21 plus, we don't know the value of N, so let us keep it just like that, N minus 1, and D is minus 3, it is multiplied. So now minus 81, if I bring this 21 to the LHS, the 21 is on the RHS, right, and it is added. So if I bring to the left hand side, that is LHS, it will be subtracted. Minus 81 minus 21 is equal to N minus 1 into minus 3. Okay, so now minus and minus, we have to add them. 1 plus 1, 2, 8 plus 2, 10, so it is minus 102 is equal to N minus 1 into minus 3. Now here the minus 3 has been multiplied. So if I bring it to the left hand side, I will get minus 102 divided by minus 3. It was multiplied here. So when I bring it to the other side of the equal to sign, it will be divided. And this is equal to N minus 1. Minus minus cancels. 3 ones are, 3 threes are, 1 remainder, 3 threes are 9, 10 minus 9, we get remainder 1, so 12, 34, right? So now 34 is equal to N minus 1. Now 34, this is subtracted here. If I bring it to the left hand side, I will get plus 1 is equal to N. So N is equal to 34 plus 1. 35 is our required answer. So minus 81 is the 35th term of our given arithmetic progression. Let us write it down. Therefore, minus 81 is the 35th term. They had asked us which term, right? It is the 35th term of our AP. Okay. Now, they have also asked us to verify if any of the terms of the AP is 0. Now, here they have given us AN is equal to 0. Once again, we have to determine which term of this AP will be 0. That is, we have to find out the value of N. So, now AN is equal to 0. N is equal to how much? A is once again 21. D is once again minus 3. We had computed it before. So now 0 is equal to, by the formula, AN is equal to A plus N minus 1 into D. So 0, AN is 0 is equal to A is 21 plus, we don't know the value of N, so it is N minus 1 into minus 3. So now once again repeating the same transposition procedures, minus 21 is equal to, because 0 minus 21 is minus 21. We get N minus 1 into minus 3. So once again transposing, we get minus 21 divided by 3 is equal to N minus 1. 3 ones are, 3 sevens are. Minus minus cancels out. So what we have here, N minus 1 is equal to 7. So N is equal to 7 plus 1. N is equal to 8. Therefore, the 8th term of our given AP is equal to 0. That is our complete solution. In the third question, they have asked us to determine the arithmetic progression whose third term is 5 and seventh term is 9. So here they have given us two ANs, that is A3 and A7, right? And we have to determine the complete AP here. So we have to find out A and D to build the AP. So let us start by writing the given. They have told us third term, that is A3 is equal to 5 and seventh term A7 is equal to 9. Okay, so now we can write it in the form of general form in the terms of A's and D's. Then I can write it as what is A3 in general term? A3 is A plus 2D, because 3 n minus 1, 2D, and A7 is A plus 60, one less, right? So now we know A3 is 5 is equal to A plus 2D, and A7 is 9, which is equal to A plus 60. Okay, here we have two algebraic equations. What I'll do, I'll just subtract them. Subtract 1 and 2. Let us just subtract them. What we'll get? 5 is equal to A plus 2D minus 9 is equal to A plus 60. Since we are subtracting, the signs of the lower equation will change. Plus A becomes minus A, plus 60 becomes minus 60, and plus 9 becomes minus 9. So 5 minus 9 is minus 4 is equal to A minus A cancels out. 2D minus 60 we get minus 4D. Minus minus cancels, 4 ones are 4 ones are. So D is equal to 1. We found our common difference. Now it is time to find A. Put the value of D in either of the equations 1 or 2. You will find A. Okay, I'll put the value of D in equation 1. Put in equation 1. You can also put it in equation 2. You will get the same value. 5 is equal to A plus 2 into 1. Because D is equal to 1. So 5 is equal to A plus 2. So now simplifying for A, we get A is equal to 5 minus 2, 3. This is the value of A. So now we have our A and D. We can easily build our AP. Therefore, the AP is, first we write 3. Next term is A plus D, that is 3 plus 1, 4. Next term is 4 plus 1, 5, 6, 7, and so on. So our third term is 5, and if I go on like that, like this, then our seventh term will be 9. Okay, this is our solution. Okay. In the fourth question, they have asked you to check whether 301 is a term of AP 5, 11, 17 and 23 and so on. So given AN, right? It is AN. They have given us some term, that is 301, and they have asked us to verify if that term belongs to the given AP. And from the AP we get that A is equal to 5, D is equal to 11 minus 5, which is equal to 6. The difference between neighboring terms. Okay. So now we have to find N. Right. If we find N, then we'll be sure it will be proved that 301 belongs to the given AP. Okay. So we know that AN is equal to A plus n minus 1 into t. So an is 301, a is 5 plus we don't know n, so we are finding that. Keep it as it is. And d is 6. We found d. So now once again 301 minus 5, because it was plus here, after transposing it becomes minus. We have n minus 1 into 6. So now 301 minus 5, what's the value? 11 minus 5, 6, 29. So it is 296 is equal to n minus 1 into 6. So now it is multiplied here. After transposing to the LHS, it will be 296 by 6 is equal to n minus 1. So since both are even numbers, let's try cancelling them. It will be equal to 2 3s are, 2 1s are, 2 4s are, 2 8s are. So it is 148 by 3 is equal to n minus 1. So now n is equal to 148 by 3 plus 1, because it was subtracted here. So now there is no LCM here, so LCM will be 3 and 1. Denominators, the LCM is 3, and 3 1s are 3, multiply by 1, 1 3s are 3, multiply by 1, multiply by 3. So it is 148 plus 3, which is equal to 151 by 3. So here we got our value of n to be a fractional number. Do you think that in an AP the terms can be fractions? Do we have half the term in an AP? The 3 by 5th term in an AP? Is it possible? No, it's not possible, because in an AP there is always first term, second term, third term. The terms are never ever fractions. N is always a natural number. So obviously we can say that therefore 301 does not belong to AP. It does not belong to the given AP, because the value of n which we found is not a natural number. It is a fraction. In the 5th question, they have asked us how many 2-digit numbers are divisible by 3. Okay. So we know that 2-digit number starts from 10 and end at 99. We know that the 2-digit number are 10, 11, 12 and so on up to 99. 100 is a 3-digit number. So among these numbers, how many of them are divisible by 3? Okay. So the first 2-digit number which is divisible by 3 is obviously 12. If you think about it, 3 4s are 12. Obviously 12 is divisible by 3. So the very first number is 12. Then the next number is 15. Then the next number is 18 and so on. If you look at this, it forms an AP. 12 plus 3 15, 15 plus 3 18, 18 plus 3 21, 21 plus 3 24 and it goes on like that up to 99. And the very last number which is divisible by 3 is 99, right? Because 99 by 3 it gives you 33. So now we have to find out how many numbers this AP contains. That will give us the number of 2-digit numbers divisible by 3. Okay, so we have an is equal to 99, a is equal to 12, d is equal to 15 minus 12 which is equal to 3, and we have to find n is equal to what? Okay, so now we know that an is equal to a plus n minus 1 into d. Okay, so an is 99 is equal to a is 12 plus we don't know n, so we'll keep it as it is, and d is 3 multiplied by 3. So now 99 minus 12 is equal to n minus 1 into 3. 9 minus 2 9 minus 2 7, 9 minus 1 8, 87 is equal to n minus 1 into 3. So 3 ones are 3 2s are 6, 3 9s are 27. So 29 is equal to n minus 1. 29 is plus 1 is equal to n. Agree? Because n it was subtracted here. When I bring it to the other side, it will be plus. So 30 is equal to n. Is our answer. So therefore 30 two-digit numbers are divisible by 3. Okay, let me give you another question. Pause the video and solve it. Write down example. How many two-digit numbers are divisible by 2? Okay, find out how many two-digit numbers are divisible by 2. You have to follow the same method. Okay, pause the video and try solving it. Okay, moving on. In the 6th question, they have asked us to find the 11th term from the last term of AP 10, 7, 4 and so on up to minus 62. Here in this question, the trick is they have not asked us to find the 11th term. Okay, if in an AP, if I were to tell you to find the 4th term, you will start from A, right? A plus D, A plus 2D and A plus 3D will be your 4th term. But here the trick is that they have asked you to find the 11th term from the end of an AP. You have to come in reverse order here. So first let us write it down. Given 10, 7, 4 and so on up to minus 62. So here A is equal to 10, D is equal to 7 minus 10 which is equal to minus 3 and AN is equal to minus 62. Okay, so now if I were to write this AP in reverse order, okay, if I were to write it in reverse order, how will it look? Minus 62 and the next term will be minus 59, right? Because the difference is minus 3 when I write the AP in the given order, the order in which they have given in your textbook. If I write the AP in that order, then the common difference is minus 3. Now I am trying to write the AP in reverse order. Then the common difference will have the sign plus 3. Okay, so now minus 59 and the next term is minus 56 and so on up to 10. Now can you not find the 11th term of an AP? Pause the video and try to find the 11th term. I will tell you the answer. The 11th term is A11 is equal to minus 32. Okay, try finding the 11th term. This is your answer. This should be your answer. Pause the video and try to find the 11th term. Okay, and another method to do this sum is to find how many terms are there. They have given us the AN, that is minus 62. You have to calculate N and then find the 11th term from the end of the arithmetic progression. Okay, try solving it on your own. In the 7th question, they have told us that a sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. So they have deposited like 1000 rupees in the bank at an interest rate of 8%, and we have to calculate interest at end of each year. Like at end of first year, how much will be the interest? At end of second year, what will be the interest? At end of third year, once again interest. We have to calculate the interest at end of each year. Also, continuing, they have asked us if this interest is in the form of an arithmetic progression. Okay, and if it forms an arithmetic progression, they have asked us to find how much interest will we have at the end of 30th year. That means they have given us n is equal to 30 and they have asked us to calculate AN if the interest form an AP. So now I hope you guys remember how to calculate the simple interest. Simple interest is given by the formula SI is equal to PTR by 100. I hope you remember this because given, we have to calculate it, right? Given the principal amount is 1000. We have time. Time is end of each year. So time is 1 year, 2 years, 3rd year, 4th year, like that. Rate of interest is 8%. So I is equal to how much? So for first year, I is equal to 1000 into 8 into 1 PTR. The time was 1 year here, right? Divided by 100. Cancels out. What we have is rupees 80. So for second year, I is equal to 1000 into 8 into 2 by 100. Why 2? Because it is the end of second year. 2 years have passed now. 0, 0 cancels out and what we have is rupees 160. Now at the end of third year, the interest will be 1000 into 8 into 3 divided by 100. So 8 3s are 24. The answer interest is rupees 240. Now and it goes on like that. Okay, it goes on like that. Now let us look if this forms an AP. The interest rates are 80, 160, 240 and so on, and obviously they form an AP. If you look at the differences, 160 minus 80, 80, 240 minus 160, 80. There is a difference of rupees 80 every year, so it forms an AP. So I can write, therefore the interest forms an AP with A is equal to 80 and D is equal to 160 minus 80, which is equal to 80. So now, since it forms an AP, we have to find the interest at the end of 30th year. That is, A30 is equal to how much when N is equal to 30, end of 30th year. So we know that AN is equal to A plus N minus 1 into D. AN is, we don't know AN, we have to calculate it. A is 80 plus N is 30 minus 1 into 80. So 80 plus 29 into 80. What will be the answer? 80 plus 8 9s are 72, 7, 8 2s are 16, 16 plus 7 is 23 and 0 because it is 80, 2320. So 80 plus this will be 2400. Therefore, at the end of 30th year, the interest is rupees 2400. In the eighth question, in a flower bed there are 23 plants in the first row, 21 plants in the second row, 19 plants in the third row and so on, and the last row contains 5 plants. You are supposed to calculate how many rows does the flower bed have. Okay, if you look at it carefully, then the number of plants in each row will be 23, 21, 19 and so on up to 5 plants. They have given you A, D, an, and they have asked you to calculate n. So pause the video and calculate the value of n, and it should be equal to 10. You can pause the video, calculate and verify your answer, which should be equal to 10. Okay, here given is the first sum from your second exercise of the arithmetic progressions. The question is, fill the missing blanks from the table. They have given you a table where 5 arithmetic progressions are given, and their A, D, N and AN have been mentioned. Okay, you have to find the missing places. In some places AN is missing, in some places D is missing, in some places N is missing. So you have to fill up those places. That means you have to calculate the values of N, D, AN or A for particular blank. Okay, in the first blank you have to calculate the value of AN. In the second you have to find the value of D. In the third you have to find the value of A. In the fourth you have to find the value of N, and in the fifth you have to find the value of AN once again. So this is your homework for the day.